This is the classic of all classic AP Calc questions, right? So they're giving you a piecewise function up at the top, which oftentimes freaks people out just to begin with. And then they're giving us three statements down below that they want us to see if any of those statements are true about our original function up here. Remember that when you're reading a piecewise function, how this works is you kind of look at the right-hand side first. And what this is saying is for x values that are not equal to 2, I would use this equation right here. And then that one moment in time when x does equal 2, I would use this equation here. So that's how a piecewise function works. It always starts on the right-hand side, and you see what your x fits into. Now, if we look at the three things we're being asked to determine if they're true or not, the first one here is asking us to determine if f has a limit as x approaches 2. This could be a left-hand limit. They're not being clear, so this could be a left-hand limit. This could be a right-hand limit. This could be an overall limit. And so I would want to check if one of those is true or not. Then the second line wants us to see if this thing is continuous or not. In order for something to be continuous, the definition of continuity says the limit as x approaches that number, so in this situation 2, has to equal the function value there. So the limit has to equal the y value. What I always say is the limit needs to equal the actual dot on the graph. So where you would put a dot on the graph so you know there's not a hole in the graph there. You'll notice that, in order to see if something's continuous, you had to figure out the limit anyways. So question one's answer sort of leads into, or option one's answer leads into option 2 here. Then the last piece, the third one, wants us to determine if this is differentiable or not. Well, there's two things you have to know if something's going to be differentiable. First, it has to be continuous. And if it's continuous, it also needs to be what we refer to as, a lot of people use the common terminology smooth. It means we want no corners, no sharp pieces, no corners, no cusps. We don't want verticals in there. So this thing needs to be smooth. In order to show if something's smooth or not, I just sort of use the terminology, does my left-hand derivative, so does f prime of 2 coming from the left side, does that equal my right-hand derivative? So f prime of 2 coming from the right direction. And if those two things are equal, then that means my derivative value, my slope at those points was the same, and therefore it's smooth. If those two things are not equal, then what that tells me is that I'm looking at some sort of sharp corner here, and therefore I would not have a derivative. Again, like we saw with 1 and 2, 1 leads into 2. Well, because in order for something to be differentiable, it has to be continuous, the answer to 2 can quickly tell us if we even need to worry about 3, right? If it's not continuous, if it fails number 2, then there's no way it could be number 3. And so work your way from the top down in a situation like this, because if you run into something that doesn't work on one of them, that immediately tells you that the next one isn't going to hold up. So you don't even have to bother with some of this extra work. So we'll start with option I right now. Does the limit as x approaches 2 of our f of x, does that have a value? So f of x in our situation, because we're worried about what's happening as we approach 2, we would be using the top equation here because we just want to know what's happening as we come close to 2, not what's happening really at 2. And then what I always tell people, never forget option 1. Option 1 on a limit problem is always going to be a plug it in and see what happens. So here, if I plug in 2 for x everywhere, I end up getting 2 squared minus 4 over 2 plus 2, so I get 0 over 4. Which is equal to 0. There's no division by 0. There's nothing wrong here. A lot of people hop at this and think they've just immediately got to start factoring. Well, that would have, added more work than just try option 1. So we get out a value right now, which tells us that we do have a limit. We've got an overall limit. So right now, number 1 is good. So we're good to go on number 1. And that tells us now that we should go check on number 2. If number 1 had failed, then we would have been looking for a none of the above answer going on here. So number 2 is asking us if it's continuous. So what we need to do now is see is the limit as x approaches 2 of our f of x, does that equal where the dot on the graph is, where f of 2 would be? So conveniently, the way this problem works out, we know the left-hand side of this equals. We got that out from part 1 here. We know the limit as x approaches 2 of f of x, that's going to be 0. And now what we want to know is, does that equal where the dot on the graph would be? Going back up to our piecewise function, we can see that when x equals 2, which is what we're looking at right here, that the y value, the dot on the graph, would actually be at 4. And so that is saying that my limit does not equal my dot on the graph, and that immediately tells me that this is not continuous. If those two things were equal, then it would be continuous. And so right now I know that it's not continuous. And because it's not continuous, that immediately tells me that it's not differentiable. And so I go ahead and I get rid of those two. And now what I can see is that the only thing left available to me is option 1. 1 was the only thing that worked. The limit did exist, and everything else did not. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.